So welcome to this video segment, and I want to show you how you can actually calculate errors, especially in your mathematics paper 2 under estimations. So the basic idea that you need to remember is that they are going to ask you to find what we call as being the least unit. Sorry for that. So the least unit of measurement, which we abbreviate as LUM. So the least unit of measurement. So when it comes to the least unit of measurement, there are two things that you need to remember. You may be given a decimal. Let me start with a whole number. So you may be given a whole number. So if you are given a whole number, in this case, you need to know that for a whole number, for example, I may give you 5, I may give you 45, or any whole number. So the least unit of measurement for a whole number is simply 1. So if I wanted the least unit of 45, because this is a whole number, it simply means the least unit of measurement will also be 1. And that's what you need to remember. Then 2, you may be given a decimal number. So now, if you are given a decimal number, how do you find the least unit of measurement? For example, if you have got maybe 4.1, if it is the one decimal place, then the least unit of measurement is going to give you 0.1. So you put up like a 0 before the point and afterwards, because you can't put a 0 there, and it simply means that you're going to put up 1. No wonder we're having 0.1. Suppose I had 1.23, then what was going to be the least unit? Well, the least unit of measurement was going to be 0.01. How am I coming up with that? Remember, before the decimal point, put up a 0, then a point, then this digit there will represent a 0, then the last digit will be a 1, and that's the way we are getting that one. Suppose you had something that looks like 42.124. Then what would have been the least unit? Of course, it would have been 0.001. Remember, I said before the decimal point, you have to have a 0 point. These two digits are 2 zeros, then the last one is supposed to be 1. So that's the way we get the least unit of measurement. So for a whole number, it is just 1. So for a decimal number, it will depend the number of decimal places, so that will determine the least unit of measurement. Now, why is the least unit of measurement important? Well, it is important, one, because it will help you to find what we call as being the absolute. It will help you to find the absolute error. So with the absolute error, you get the least unit of measurement, then you always divide it by 2. So that's the way we get the absolute error. So another way of getting the absolute error, you need to remember all these concepts. So another way to get the absolute error, you can simply say the modulus of the recorded, let me say that the recorded measurement or value, let me say the recorded measurement of value minus, in this case, the true measurement, or let me say the true value that you have. So you have the modulus. So meaning the answer may be sometimes negative. So if you have a -9, because of the modulus, it means that the final answer is going to be a positive. So you can either use that or use that, and that will help you to find that. Another thing that they are going to be asking you that you need to know is what we call as being the relative the relative error. So with the relative error, it is equal to the absolute error divided, in this case, by the true measurement or the true value. So when you find in its lowest form the absolute error over the true value or the true measurement, that is what we call as being the relative error. Then the last thing they are going to be asking you to find is the percentage error. So how do you get the percentage error? Remember, absolute error, I will abbreviate it as AE, then the true value or measurement, I will represent it by that. So for the percentage error, for you to get it, you need to say the absolute error divided by the true measurement or the true value, then you express it as a as a percentage. So these are concepts that you need in your paper 1 in order to answer, such questions. You're going to see as I try to demonstrate that. The last thing that you're going to do, the last thing that they're going to ask you is to calculate what we call as being the tolerance. Now the tolerance is simply the difference between the highest value, in other words, what we call as being the upper limit. So the difference between the upper limit minus the upper limit, I'll simply say, UL minus the lower limit. In this case, I'll say L, L. So that's the lower limit. So the difference between the two, that gives you the tolerance. But you can also find the tolerance by simply saying, the tolerance, will be equal to, you say 2 multiplied by the, what we called as being the absolute error. So if you know the absolute error, just multiply it by 2, and that will give you the tolerance. I hope I summarized the concept well for you so that you are able, to calculate this in your exam. So that is basically what you are going to do. Now, let's come back to now these examination questions so that we show you how you need to go about, answering them. So according to the question, it says, the first one there says the length of a piece of wire is measured as 4.5 centimeters. Then it says calculate A, the tolerance. So remember, since it is measured, according to that question, it was the length was actually, so the length was actually measured as 4.5 centimeters. And the question says we find the tolerance there. So remember, you need to know the least unit of measurement. So the least unit of measurement for this value will be 0.1. Hopefully you remember from what I talked about. So if you are able to find that, you can now know, you need now to know the absolute what? The absolute error. So how do you get the absolute error? You get the least unit of measurement 0.1, you divide it by 2. Now oftentimes, students actually struggle to divide that. What you can do when you find such a situation, you can ignore the decimal point. So the meaning the number on top is just like 1 over 2. So you can work out with that. Can 2 go into 1? The answer is no, so it will be 0. And you write a point and add a 0. 2 into 10 will give you 5. But because this was the 1 decimal place, so you move that 1 decimal place backward 1 time. So meaning when you divide this, it will give you 0.05, and that is your absolute error. But remember, this is not the final answer. The question was saying we calculate the tolerance. So meaning that the tolerance there is going to be equal to 2 multiplied by the absolute error. So it will be 2 times the absolute error, 0.05. So that's what we mean. So it will be multiplied by 0.05. So when you multiply that, again, students are struggling to multiply that. This is very easy if you are having that. So let me just do it from here. 0.05 times 2. If you wanted, you'd have said 5 times 2 to give you 1. Then you count the number of decimal places backwards. So that is 2 times 5 is a 10. So we write a 0 carry 1. 2 times 0 is 0 plus 1 will give me 1. 2 times 0 will be a 0. So but this number on top are 2 decimal places. So you move the point 1, 2. So the point will be here. So this value will be the same as 0.1. So that is the tolerance that you can have there. So that's what we mean. All right. Hopefully you got, the sense of what we are talking about here. Now, another thing that I want to highlight for you, would have also calculated this question in this way. Before I come to the B part, let me show you how that value would have been written. So would have also said, because we calculated the absolute error as 0.05, you would have written this length as 4.5 plus or minus 0.05, and the whole of this would have given you the centimeter. So this value that you have here is actually the true value, and this one that you have here is the absolute what? Is the absolute error. So you would have found the upper limit and you would have also found the lower limit. So how do you get the upper limit? You can simply say 4.5, then you say plus 0.05, and for the lower limit you simply take 4.5 minus 0.05. So that's what we are doing there. So if you add that, I'm going to, remember, take note of our tolerance, it was 0.1. I'm showing you a different method from what I discussed there. So it is actually 4.5 plus 0.05. Remember, when you're adding or subtracting, the points are supposed to be in the same line. Here you can add a 0 deliberately. 0 plus 5 is a 5. 5 plus 0 is a 5.4. So that will give you 4.55. Then for the lower limit, I would have said 4.5 minus 0.05. Again, you can put up a 0. You can get 1 from there. 10 minus 5 is a 5. They have remained with 4. 4 minus 0 is simply a 0.4. So meaning that the lower limit is simply 4. Sorry, here this is supposed to be 4.45. So now, like I told you, the other way of calculating the tolerance, so we would have said tolerance is equal to what we called as being the upper limit minus the lower limit. So when you get this one, 4.55 minus 4.45. So just subtracting the 2. Let's see that 4.55 minus 4.45. 5 minus 5 is a 0. 5 minus 4 is a 1.4 minus 4 is a 0. You can see that you are getting still a 0.1. So the first one that I showed you is the easiest that you can go about, instead of finding the upper and the lower limit. But again, that will depend with the situation that you have actually been given. All right. So now let's go to question number 1b and answer that question that you have there. So 1b was saying the relative error. So since we found the absolute error was simply 0.05, and we want to get the absolute error. So B, the relative, we want to get the relative error, the absolute error. The relative error is equal to the absolute error divided by the true measurement or the true value. So the absolute error is 0.05 divided by the true value. Remember, that's the true value there they gave you, which is a 4.5. Now, in the exam, people are struggling with that. You don't need to struggle when you find that. You ask yourself on the numerator and the denominator. The numerator has how many decimal places? 2, and the numerator has 1. So you go for the highest number of decimal places because this one has the highest. So if it has got 2, meaning you multiply by 100. If it had 1 and you wanted to move the point, you multiply by 10. But if I've got to 2 decimal places, you multiply by 100. If I've got to 3 decimal places, then you multiply by 1000. Now, since here it has only to 2 decimal places, that's the high, so I'll multiply by 100 on top. I'll also do it the same at the bottom. So when I multiply by 100 on top, I'll just remain with 5 over here. I'll move the point twice, 1, 2, so it will become 4, 5, and 0. So now you can just reduce it to its lowest terms. For 5 there is 1 over, 5 into 45, that's 9 and a 0. So meaning that the final answer is 1 over 90. And that is your relative error that they wanted you to get. Hopefully, I'm helping you so that you are able to answer questions in the, exam as you sit, for the upcoming exams that you are going to have. Let's move on to question number 2 there. This is another examination question there that came. It says a bag of potatoes has mass. So they give you, 15.4 plus or minus 0.05. Of course, that is in kg. Remember what I told you? This value here is the true value, and this value here is the absolute error. So the first one there says, find the tolerance of this mass. So find the tolerance of this mass. The easiest is that the tolerance, since you know the absolute error, it is 2 times the absolute error. So it will be 2 times the absolute error, 0.05. 5. And I believe when you multiply that, it's like our previous one, it will give you just a 0.1. I hope we are together. Then B says that the relative error of the mass as a fraction in its simplest form. So now the relative error, let me just abbreviate it like that, is equal to the absolute error over the true measurement or the true value. So the absolute error, remember, it's 0.05 over the true value. The true value is simply 15.4. So now if you remember what I told you, the highest is the number of decimal places is the one, you know, on top there. So that's the highest. So I'll multiply this by 100. What I do on top, I also do it at the bottom. Allow me to write it from here. So this times that will just give me 5 over this. When I move the decimal point in front twice, 1, 2, it will give me 1540. That's what it simply means. So be careful as you try to reduce that. Yes, 5 can go into both numbers. 5 on top is a 1 over, and 5 into 15 is a 3. The next thing that you're going, can 5 go into 4? The answer is no, so you write a 0 here. Then you take the next number, so it now becomes 4. 45 into 40 is simply 8. So the answer here that you have is simply 1 over 308. So that is the way you could have actually gone about that. Hopefully this is helping you to have quick revisions and to get the concept, because I've tried to simplify in its simplest possible way. If you like my videos, please, you can subscribe or share with your friends so that they too can actually get to learn something. Let's move on to question number 3. It says, a piece of timber measures 5.25 centimeters long. Yeah, so it measures 5.25, meaning that's the length, in this case 5.25 centimeters long. Calculate the relative error. Remember what we said? If you have a decimal number, how do you find the least unit of measurement? Before the decimal point, a 0 point, here it will be 0 and 1. So the least unit of measurement is 0.01. Then from there, you need to know the absolute. So you need to find the absolute error. How do you do that? You get the least unit of measurement, 0.01, divided by 2. Like I told you, you don't need to struggle when it comes to that. Yeah, just ignore the points there. Just get the whole number there, which is 1 divided by 2. When you divide there, it's like, can 2 go into 1? The answer is no, so you write 0 and a point. Add a 0. 2 into 10 is simple 5. Then, because this number on top was to 2 decimal places, so you move this point going backward or to your left 2 times 1, 2. So meaning the point will be 0.005. So meaning the absolute error will be 0.005. So now once you get the absolute error there, you can now find the relative error. Remember what we said, relative error is equal to the absolute error over the true value or the true measurement. So the relative error that we have found, which is this 0.005, divided by the true measurement, which is that one, 5.25. Okay, so if you notice, the one on top there, for me to remove it, it is simply to 3 decimal places. This one is 2, so I'll use 3 so that I remove the decimal point completely. So I'll multiply by 1000. At the bottom, I'll multiply also by 1000. So when I multiply by 1000, I'm just remaining with a 5 over here. You are moving the decimal point forward. How many times? 3 times 1, 2, 3. So you have 5250. That's what you're going to have. Then you can reduce this expression there. 5 there, 1. So on top of 1 over 5 into 5 is a 1. Can 5 go into 2? The answer is no, so you write a 0 and you get the next number there. So can 5 go into 25? Yes, it is actually 5 and the last 0. So please pay attention when you are reducing, because students make, a simple mistake right there when they are dividing. So that's the way you can actually go about such problems. So you can actually go about such problems. Please watch out. I'm going to show you how to actually calculate also what we are calling as being the percentage error. So let's try to put up a question there so that you see how you can actually calculate maybe the percentage error. I'll call this one as being question number 4 so that you can look at it. It's an exam question. It was saying that the length of a line is 8 centimeters, and it says that if this is recorded, so if this is recorded as 8.2 centimeters, then it says calculate the percentage error. So that's what they mean. So calculate the percentage error. So now, how do we go about such a problem? How do we find, in this case, the percentage error? Well, it's not something that is actually complicated, no, as you are going to see as I help you, to actually, find that. So there's nothing that is actually complicated, as you are going to see. So let's go about solving that, and maybe we may look at another question. So now they have given you the length of the line, meaning that is the true value. So the true value or the true measurement is simply 8 centimeter. Then the recorded value is simply 8.2 centimeters. Calculate the percentage error. Now the first thing, you need to find what we are calling as being the absolute. So you need to find what we are calling as being the absolute error. So how do you find the absolute error when you know the true value and the recorded value? It's the modulus. Remember what I said, the recorded, if you remember from the concept, the recorded value minus the true measurement or value that you have, but put it as a modulus. So what is the recorded value? It is 8.2 minus the true value, which is 8. When you subtract that, you are going to have 0.2, which is simply going to give you just 0.2 as your absolute error. So now if you get the absolute error, now you can now find the percentage error. Remember, it is the absolute error over the true value. You just multiply it by 100%. So the absolute error 0.2 over the true value, which is 8, then multiply by what? By 100. That's what we mean there. So there's nothing complicated. So if I multiply, remember this can be over 1. 0.2 times 100, that will give me 20 over 8. We can try to reduce that value. 4 there will give me 5. 4 there is a 2. But if you look at 2 into 5 will give me a 2. Remainder 1. Can 2 go into 1? No, the answer is no. So point and a 0. 2 into 10 is simply 5. So that will give me a 2.5%, meaning that is the percentage that is the percentage error that they wanted you to get there. So you can see there's literally nothing complicated. You just need to go through your work, the concept that I've actually taught you, and hence you will be able to calculate that. Right, you can watch out for some other videos, then you can actually get to learn a whole lot from my discussion. Otherwise, thank you so much for watching. If you enjoy what I do, you can actually subscribe or join us as we venture into the learning world. Thank you.